What if I told you that exact machine started its life as exactly 2 million separate parts? I mean, 2 million. When you're dealing with a number that massive, the stakes are just unimaginably high. A single tiny mistake, that could literally cost millions of dollars, or even worse, put lives at risk. And honestly, that's exactly why every single bolt, every wire, and every massive wing is inspected, and then inspected again long before that plane ever leaves the ground. Welcome to today's Explainer. We're taking a step-by-step journey right inside Boeing's absolute mega factory. Together, we're going to see exactly how these giant commercial airplanes, the 737s, the 777s, the 787s, how they're actually built. We'll watch them transform from bare metal and scattered pieces into a complete world-crossing flying machine. And trust me on this, by the time we hit the final stage of this assembly process, it's going to completely change the way you look at air travel forever. Okay, let's dive right into this. Here is our blueprint for today. We'll start off inside the mega factory, move on to assembling the main structure, and then wire up the power and nervous system. After that, we'll check out the paint and protection before wrapping the whole thing up with final tests and delivery. Let's get to it. So let's kick things off with Section 1, inside the mega factory, where we'll look at coordinating a global supply chain. Because to really understand this assembly, we've got to grasp the sheer scale of the environment we're working in. Just think about this comparison for a second. Engineers are literally tasked with putting together an aircraft that is longer than a blue whale. A blue whale. To build something of this monumental size, you obviously can't just use a standard warehouse down the street. Boeing actually builds these advanced airplanes in enormous manufacturing facilities. Some of these buildings are so mind-bogglingly huge that they house multiple airplanes under construction at the exact same time. Inside these colossal halls, you've got thousands of skilled workers standing side by side with automated machines and robots, all following this meticulously planned production schedule. It's like a highly choreographed dance. But here's the crazy part. A Boeing airplane isn't just built in one place from scratch. The major sections like the massive wings, the fuselage, the tail, the landing gear, they are actually manufactured by dozens of different suppliers across different countries, plus other Boeing facilities. These giant components arrive at the mega factory using specialized cargo aircraft, enormous ships, trucks, and rail. It is a highly coordinated global supply chain. And the most important part, when these massive sections finally arrive at the final assembly plant, every single one is carefully and rigorously inspected before the production clock even starts ticking. No cutting corners here. Moving right along into Section 2, assembling the main structure. This is where the skeleton takes shape, and all those globally sourced parts actually start to look like an airplane. So the crucial point here is that joining these sections together, well, it's not like snapping Legos together. It requires absolutely zero tolerance for alignment errors. It all starts with forming the fuselage, the main body of the airplane. Engineers align these huge aluminum or composite sections using highly advanced precision alignment systems. They are literally using laser-guided equipment to ensure perfect tolerances. Next up, they secure everything using thousands of fasteners. And I mean it, even the tiniest alignment error here is completely unacceptable. Once the body is perfectly locked in, we get to witness one of the most awe-inspiring engineering feats in the whole factory. Heavy-duty cranes carefully lift these massive wings into position, and engineers slowly, painstakingly connect each one directly to the fuselage. It's wild to watch. Now, what's really interesting about this is when you look out the window of a plane, those wings look incredibly rigid, right? Just stiff metal. But they are actually brilliantly engineered with intentional flexibility. This critical design feature allows the aircraft to absorb heavy turbulence and intense aerodynamic forces. They are meant to move. And that flexibility is exactly what keeps your flight smooth and the structure perfectly intact. It's basically the plane's shock absorbers. And with that, we've officially reached the halfway point of the assembly. Let's transition into Section 3, Power and Nervous System, bringing the machine to life. We've built the metal skeleton, but a skeleton alone can't fly. We need to install the vital internal systems. I really want you to think about this question for a second. How do you actually bring a giant metal shell to life? When you're sitting in a comfortable cabin seat just watching a movie, you are completely surrounded by an invisible, incredibly complex nervous system hidden just behind those plastic walls. Let's take a look at exactly what that entails. The secret? hundreds of kilometers of electrical wiring. It is just astonishing. Technicians have to meticulously route all these cables throughout the entire length of the aircraft. This vast network is the nervous system that powers everything. The highly sensitive cockpit instruments, cabin lighting, communications, your in-flight entertainment, vital sensors, and of course, the flight controls themselves. And because safety is the ultimate priority, every single electrical connection is tested and then tested again before the aircraft is even allowed to move to the next station on the assembly line. Next comes the muscle, the power. Aircraft engines are quite literally among the most advanced machines humanity has ever built, and each one weighs several tons. Special lifting equipment is required just to position these massive engines beneath the wings. Once they're carefully hung in place, engineers have to perfectly secure the critical lifelines: the fuel systems, hydraulic systems, electrical systems, and control systems. And you guessed it, every single one of these connections is then checked against the absolute strictest quality standards in the industry. With the structure built and the internal systems wired, we move into Section 4, Paint and Protection. And as we'll see, this is about way more than just colors. Before an airplane can be delivered, it's moved into a giant paint hanger where the surface is meticulously cleaned and prepped. When we think of aircraft paint, we usually just think of airline identity, right? Applying those unique colors, the logos, the branding so you know exactly who you're flying with. But workers apply primer and multiple layers of paint for a much, much more critical reason: essential protection. This layered paint acts as a vital engineering shield. It protects the aircraft's exterior from brutal weather conditions and highly corrosive elements at cruising altitudes. So yeah, it's a necessary structural defense, not just a cosmetic upgrade. Finally, we reach the most critical phase, Section 5, Final Tests and Delivery, where the aircraft truly earns the skies. The Giant is fully assembled, it's painted, it's powered up, but it hasn't earned the right to fly just yet. It has to undergo some incredibly rigorous checks. Before even thinking about taking to the air, every aircraft undergoes exhaustive ground test phases. Engineers painstakingly verify the electrical systems to ensure the cockpit and sensor power is totally flawless. They test the hydraulics, checking fluid pressures and lines. They conduct a full top-to-bottom inspection of the landing gear systems. And they run extensive flight control checks to verify handling and maneuverability right there on the ground. It is only after all these strict initial inspections are successfully passed that those giant engines are finally fired up and carefully monitored for the very first time. Let's look at the timeline to see how this all builds up. Once the factory floor ground testing is completely checked off, the aircraft graduates to its first flight. This is an incredibly exciting moment where highly experienced Boeing test pilots take the brand new aircraft up into the sky. Up there, engineers are evaluating engine performance, navigation, handling, and braking in real-world conditions. If anything, and I mean anything, isn't perfect, the aircraft goes straight back to the factory for adjustments. Finally, once every single test is a complete success, the aircraft is cleaned, documented, and prepped for delivery. Pilots from the customer airline arrive, accept their shiny new airplane, and usually within days, it officially enters commercial service. It is just an incredible journey from a giant factory hall to a successful first flight. Every aircraft represents years of engineering, the seamless coordination of a massive global supply chain, and extraordinary attention to detail. So I leave you with this final thought to consider. The next time you walk down that jet bridge and board a Boeing airplane, will you look past the paint and see the invisible labor of over 2 million perfectly synchronized parts and the thousands of human hands that built the machine holding you safely in the sky? Thank you so much for joining me for this explainer.